Hey guys, so in this video we're going to go over the rules of integration. So we're going to look at common expressions and their respective integrals. The first rule that we have is if we're integrating a constant with respect to x. Here a is a constant and we're integrating a with respect to x, and the integral of any constant with respect to x will simply be that constant times x plus a constant of integration. So for example, if we were integrating the constant 2 with respect to x, the integral of 2 with respect to x would simply be 2x plus c. And again, since we know that integration is the reverse process of differentiation, we know that if we had any expression of the form 2x plus c, its derivative would simply be 2. Next, what if we had to integrate something of the form ax to the power of n with respect to x? Here, x to the power of n is being multiplied by this constant coefficient a, and one of the properties of integration here is that if we have a constant coefficient multiplying something, we can always factor out that constant coefficient. So the integral of ax to the power of n with respect to x is equal to a times the integral of x to the power of n with respect to x. This rule is referred to as the power rule. If you had to integrate something of the form x to the power of n with respect to x, we would increase the power by 1, so we would get x to the power of n plus 1, and we divide by the new power, so we divide by n plus 1, and obviously we have our constant of integration c over here. This rule is valid for all powers of x, that is n over here, except n is equal to 1. So for example, if we had to integrate 6x squared with respect to x, here what we're going to do is we're going to increase the power by 1, so 6x squared will become 6x cubed, and we're going to divide by the new power, so we have 6x cubed divided by 3 plus our constant of integration c, so the result is 2x cubed plus c. So the integral of 6x squared with respect to x is 2x cubed plus c. And again, we know that since integration is the reverse process of differentiation, if we had something of the form 2x cubed plus c and we found the derivative of that, we would get 6x squared. We would simply do the reverse process. For integration, we increase the power and divide by the new power. For differentiation, we'd multiply by the power and decrease the power by 1. Here we have another example. We have to integrate 3 times the square root of x cubed with respect to x. Here we can see that 3 is simply a constant coefficient, so we can factor that out. And x to the power of 3 under root is simply x to the power of 3 over 2. So if we integrate x to the power of 3 over 2 with respect to x, again we increase the power by 1, so 3 over 2 plus 1 is 5 over 2, and we divide by the new power, so we divide by 5 over 2, that's the same as multiplying by 2 over 5, plus c, that's the constant of integration. So our integral is 6x to the power of 5 over 2 divided by 5 plus c. The next rule that we have is closely related to the power rule, but here, instead of integrating x to the power of n with respect to x, we're going to integrate this linear expression ax plus b, the whole thing, to the power of n with respect to x.
Quick pause. If you're finding value in this explanation, there's so much more to discover. At Alt Academy, we break down every A-level concept with the same level of clarity. Now, let's continue.
Here again, we increase the power by 1, so ax plus b to the power of n becomes ax plus b to the power of n plus 1. And we divide by the new power, so we divide by n plus 1 here. But we also divide by the derivative of the expression itself. The derivative of anything of the form ax plus b will simply be a, so we also divide by a. And then obviously again we have plus c here, which is a constant of integration. And this rule also applies for all powers n except n is equal to 1. So for example, if we had to integrate 2x plus 5 to the power of 3, what we can do is we can increase the power by 1, so we get 2x plus 5 to the power of 4, and then we divide by the new power, that's we divide by 4, and we divide by the derivative of 2x plus 5, that's just the coefficient of x here, so that's 2. So then we get this expression, and if we simplify, we get 1 over 8 times 2x plus 5 to the power of 4 plus our constant of integration c. Here's another example. Here we have to integrate the square root of 3x minus 7 with respect to x. Now square root of 3x minus 7 can be written as 3x minus 7 to the power of 1/2. And we have to integrate that with respect to x. So again, we increase the power by 1. So 3x minus 7 to the power of 3 over 2. We divide by the new power. So we divide by 3 over 2. That's the same as multiplying by 2 over 3. And we divide by the derivative of 3x minus 7. The derivative of 3x minus 7 is simply 3. And this equates to 2 over 9 times 3x minus 7 to the power of 3 over 2 plus our constant of integration c. Now the last thing to note over here is that if we had to take the integral of a sum or a difference of terms, then that would simply be the sum or the difference of the integrals of each of those individual terms. So for example, if we had to integrate the following expression, where we have a sum or a difference of 3 different terms in x, we can simply take the integral of each individual term and combine them to get our final result. So in order to integrate this, let's first write everything in the numerator. So we have the integral of 4 divided by 2x minus 3, the whole thing squared. So that will be 4 times 2x minus 3 to the power of negative 2, plus 2 divided by square root of x is simply 2 divided by x to the power of 1 half. So that would be 2x to the power of negative 1 half minus 8x cubed. And we have to integrate this with respect to x. And we can do that by integrating each of these terms individually. So for the first term, we have 4 times 2x minus 3 to the power of negative 2. So what we're going to do is we're going to increase the power by 1. So 2x minus 3 to the power of negative 2 becomes 2x minus 3 to the power of negative 1. We divide by the new power, so we divide by negative 1, and we divide by the derivative of the expression inside the parentheses. This is referring to the third rule that we saw. So we divide by the derivative of 2x minus 3, so we just divide by 2 here. For the second term, we have 2x to the power of negative 1 half. Again, we increase the power by 1, so we get 2x to the power of 1 half, and then we divide by 1 over 2. We divide by the new power. That's the power rule here. If we divide by 1 over 2, that's the same as multiplying this by 2. And for the last term, again, we have the power rule here. So we have negative 8x to the power of 3 that we have to integrate. So what we're going to do is we're going to increase the power by 1. So it'll become 8x to the power of 4. And we're going to divide by the new power. So we divide by 4. And of course, we also have our constant of integration, c. So then what we get over here is we get 4 divided by negative 2. So that is negative 2 times 2x minus 3 to the power of negative 1. So that is minus 2 divided by 2x minus 3 plus 2x to the power of 1 half times 2. So that would be 4 square root of x minus 8x to the power of 4 divided by 4. So that would be 2x to the power of 4 plus c.
Now that that's taken care of, head over to our website to watch the rest of our A-Levels maths course. With 60,000 students trusting us, visit All Academy now and transform your A-Levels journey.